In this video, I will show you how to apply symmetry conditions in SolveX simulation, some considerations when doing so, and a quick tip to make the plots look nicer. First off, when using symmetry, we need to be sure that both geometry and the loads and boundary conditions are symmetric. For this example, I have already done a study on the full model. It is restrained by hinges in both holes and loaded with 1000 newtons on the top face. I'm using a global mesh with an element size of 2 mm. Looking at the solver message, we can see that this simulation took 22 seconds to run. The reported maximum stress is 8.5 megapascals and the results look symmetric. The reported maximum displacement is 0.01 mm, and again we can see symmetry in the results. In this case, we have two possible symmetry cuts along the YZ plane and along the XY plane. I will therefore define a study on half of the model and a study on a quarter of the model and compare them all at the end. First, I will create the half symmetry study from scratch by switching to the configuration and making a new study. I'll apply a hinge fixture to the remaining hole. And to tell the study that I am taking advantage of symmetry, I also need to apply an advanced fixture. Select symmetry as type and select the face of the symmetry cut. I will also apply the load to the top, but remember to only use half the load when you are simulating half the model. I'm creating a mesh with a maximum element size of 2 mm so that the studies are easily comparable. And then I run the study. The stresses are approximately the same as earlier, and so is the displacement. Looking at the solver message, we can see that this simulation took 13 seconds, which is quite a significant reduction from the 22 seconds it took for the full model. To create the quarter study, I will copy this one and make sure to change the configuration to the one you want in the new study when copying. Right-click in the simulation feature tree to activate the configuration. Now I need to apply an extra symmetry boundary condition in the same way as I did before to tell the solver that this is also cut along the XY plane. Since we are now simulating a quarter of the model, we need to change the load accordingly. My mesh definition is copied from the half study, so I will mesh and run this in the same operation. The stresses are approximately the same as earlier, and so is the displacement. Looking at the solver message, we can see that this simulation took 7 seconds. The easiest way to visually compare all simulation is to use the compare feature, and in this case I will look at the stresses in all studies. There is a slight deviation in the results, but this is below 0.1%, and it could be caused by the elements being placed slightly differently in the different studies. The last thing I want to show you in this video is how to make the plots on the symmetric model visually better. To do this, activate the plot you want to change, edit definition, and under advanced options, select display symmetric results. The results are mirrored on the symmetry planes and we have a plot that looks more or less exactly the same as the full model plot, but done in about 1/3 of the time.